Okay, so you want to know all about nucleophilic substitution mechanisms, don't you? I know you do. Admit it. Yeah? Okay, let's do this. Not difficult. By the way, this is for year one. You know that already, right? Let's do it. So, this equation, oh, by the way, the examiners, they actually love these letters, you know that. Yeah, they love giving you these reaction mechanisms, and then they're saying, you know, labeling each of them with different letters, and then asking you questions about these. Why? Because they've found that the students often get confused just by the fact that they're using letters, right? But forget the letters. Let's just start with a question. Let's see what happens. Forget the letters. Let's see what happens. Read the question. Give the IUPAC name. Consider the following schemes of reactions. So they're giving you these schemes, and then they're saying, give the IUPAC name for the compound P and that for compound Q. So there's my P and there's my Q, and they want the IUPAC name. Remembering all the IUPAC rules, you know, the numbering system, etc., etc. Okay, so let's start. So here's my P. The IUPAC name. Now immediately I'm thinking, okay, well there's my functional group, and that's the only functional group in the whole molecule, and therefore that functional group will need to be part of the main chain. Okay, so I'm thinking, okay, which is the longest chain? 1 2 3 4 1 2 3 4 1 2 3 4. Okay, so it's 4 carbons whichever way you look at it. So I'm going to consider that to be my main chain. Okay, and of course I'm going to make sure that this double bond is in the lowest number of carbon possible, right? So this is obviously 1 2 3 4 bute, and of course starting from this side, because that will give me the lowest number, it's bute 1 ene. Okay, so it's not bute 1 2 3 ene, no, it's bute 1 ene. Okay, so let's start writing that down. So bute 1 ene. Okay, and of course then I need to consider the side chains, and there are 2 side chains, aren't there? Yeah, and they're both methyl, so I'm going to put methyl, right? But there's not 1, there's 2, so I'm going to put dimethyl, right? Dimethyl, butene. But where are these 2 methyl groups? And they are on carbon number. Now remember, I've seen students do this where they start changing the ordering suddenly. So they started with that carbon to name the sort of double bond there, so it's bute 1 ene. But then for these side chains, they'll suddenly start here again. They'll say, oh, 2, right? No. And once you've started, you know, from one side, because of a functional group, then you have to keep numbering it from that side. Okay, so carbon, so that's 1 2 3, so it's actually 3, so carbon number 3. And of course, because there are 2 methyl groups on the same carbon, I have to put 3, 3. Yeah, dimethyl. So I'm going to rewrite that again so it's a little bit clearer. 3, 3, and then I'll say a little bit about it, about numbering. Bute 1 ene. Now, you're not going to lose marks on this. However, you're a chemist, okay? You want to impress the examiners, and so you're going to follow all the chemistry rules that need to be followed. So for example, look at this. There needs to be a comma between numbers, all right? And there needs to be a hyphen every time there's a between a number and a letter. A hyphen between a number and a letter. A hyphen between a number and a letter. A hyphen between a number and letter, yeah? You're doing this because you want to impress the examiners, and you want to tell them, look, mate, you know, I know what I'm doing, all right? You don't need to look at my answers very closely, yeah? Just, you know, just do it, okay? So follow all the conventions, yeah? Impress your examiners. So for the remainder of the exam question, they're saying, actually, this person seems to know what they're doing. Let's just like look at it very sort of briefly and quickly, all right? Do it. Right, okay. So that's P done. Q, let's now look at the Q. So Q, again, the only functional group I can see is that chlorine here, okay, on the carbon. So I'm going to try and keep that the smallest number of carbon, and also now let's look at the longest chain. 1, 2, so it's the same chain, so obviously it's going to be like that. So I'm going to name that like that. So there's my longest chain. So I'm going to say, okay, give it the smallest number. I'm going to have to start counting from this side. 1, 2. So it's 2 chloro. 2 chloro. And then continue from this side as well, again, because I've started counting from this side to give me the smallest number here. And then it's 2 chloro, then it's 3. So this is the third carbon, 1, 2, 3. And there is 2 dimethyl, so I'll keep writing it too far to the side. I apologize, I'm going to start again. So I'm going to start, give it plenty of space. So 2 chloro. And then, 2 chlorobutane, obviously. And this time it is ane, not ene. And then, of course, dimethyl. Right? Dimethyl. So 2 chloro dimethyl butane. But the thing is, I need to tell them where this dimethyl is. I need to tell them where this dimethyl is. Where are these 2 methyl groups? Okay, and these 2 methyl groups are on the third carbon, and because there are 2 of them, I need to put 2 numbers. There you go. Now, I'm gonna check something, because I'm gonna make sure that these numbers, lots of numbers there, but they're the smallest ones I can get. Okay, so now what if I count from this side? Okay, so that is number 2. So I'll get 2 dimethyl 3 chlorobutane. So I'm going to get this. So if I count from this side, my numbering will be 2 dimethyl butane. Okay, and then it will be 3 chloro. Yes, the 3. So that is on a bigger carbon, but I'm getting more smaller numbers than I'm getting the bigger one. Do you get it? I'm getting more smaller numbers than I'm getting the bigger one, right? So what that means is that I am going to use that as my name, because that gives me more smaller numbers. Yeah, 2, 2, whereas this is 3, 3. So this is 3, 2, 2, 2, 3, 3. So I'm going to use that. However, they will accept this as well. But remember what I said, impress the examiner, use the correct ones. Okay, so that is the correct name. Right, let's move on to the next one. The conversion of P into Q in reaction 1 uses HCl. So there's my reaction 1 going from there to there. Uses HCl. Name and outline the mechanism for this reaction. Now, I don't know about you lot, but I actually end up doing the mechanism, drawing the mechanism, or outlining the mechanism before I name it, because then I understand what's happening. But if you know the mechanism just by looking at it, and you can name it initially and then outline it, entirely up to you, your choice. Okay, so outline the mechanism for this reaction. Right, let's do this. So it's going from, what I'm looking at is going from there, so that's changing, isn't it? Yeah, so that double bond is changing to that. So obviously something's happening around the double bond. There's an extra hydrogen there, an extra chlorine there, so HCl is being added across this double bond here. Okay, so it's obviously, now the first thing that I'm thinking also, so one of the things that I'm thinking is what's going on here. So what kind of a reaction will it be? It will be obviously double bond, so something that likes electrons, so therefore it must be electrophile. Okay, and then things are being added, so electrophilic addition. Yeah, okay, but let's do the mechanism. I'm going to outline the mechanism. So my thinking is, even though I said I often draw the mechanism first, electrophilic, however, this was quite easy. Electrophilic addition. Okay, let's do the mechanism. Now the mechanism is, now I'm going to have to draw this because I need to highlight a few things for you. Right, whenever I am doing a mechanism, I always write the electrophile, etc. in the same place every time, because that helps me to remember what happens in the mechanism. And my suggestion to you lot would be do the same. Yeah. So for example, what I'm going to do is electrophile. There's my double bond, isn't it? So my electrophile will always go here. There's my HCl. Okay. And then of course, then I'll know, well actually, hold on a second, fair enough. So you know, the arrows, so these electrons, one pair of these electrons will be transferred to the H to make a bond between that H and one of the carbons, okay? And then what's going to happen is, of course, if that's going to make a bond with that using these electrons, it doesn't need these ones. So they're going to get transferred to the chlorine here, or to the chlorine atom on this side. And then the next step, of course, you're going to have to do is remembering to just continue to take the rest of the molecule with you, technically speaking, obviously. There's my hydrogen already there. And then, of course, now the question is, where is this hydrogen going to bond, this extra hydrogen going to bond? Is it going to bond here, or is it going to bond here? Well, Markovnikov's rule, you remember that Markovnikov's rule, yeah? Markovnikov's rule, if you don't look it up, the hydrogen will bond to the carbon, which has already got more hydrogens bonded to it. Okay? Okay, look it up why. I'm not going to tell you why, you look it up why. Okay, Markovnikov's rule. So what happened was that these electrons have been transferred to that side, chloride. These electrons have been transferred to that side, hydrogen. And of course, this becomes a carbocation. And then of course, this chloride ion with its lone pair of electrons and negative charge attacks that carbon to to bond to it. And I'm just drawing the final product for you, even though in the exam, you do not need to draw the final product. Okay, and that, oh sorry, this is supposed to be chloride. Okay, and there you go, that's your final product. Now, marks. I always say to my students, in mechanisms, arrows are important. Arrows always need to be double-headed arrows. So when I say double-headed, I don't mean a head here and a head here. I mean, you know, these two sort of prongs, not that, but that. Yeah, that's double-headed arrows. Okay, so what that means is, okay, so arrows are important, right? So arrows have to start from electrons and end up at an atom. Start from electrons, end up at an atom. And it needs to be precise. What did I say? It needs to be precise. Why? Because in a rush, in the exam, you can't suddenly turn around and say, well, you know what, I'm going to do this, and there's my, yeah, that's fine, yeah, no, you know what, that's fine, you know. I mean, I don't know whether that arrow is going that way or what, okay? Where is it starting from? Is it starting from there? So be precise. Be precise. When you're doing mechanisms, you've got to be precise, okay, with your arrows. Otherwise, you will lose marks, okay? Here, again, I'm starting from electrons, and I'm going to the actual carbon, and there's no two ways about it. There's no doubt about it. I'm doing it. Okay, you can see it clearly. Okay, so please be precise. Right. Now marks. So every arrow will get you a mark. 1, 2, and 3 marks. You will not get a mark like that because they've shown you the product itself anyway. Yeah. So anyway, so that's 3 marks. Okay, so 1, 2, 3, and you'll also get a 4th mark for the correct carbocation structure. Yeah, making sure that the carbocation is the middle carbon and not the end one. Markovnikov's rule. Yeah, look it up. Okay, so that's the mechanism, and of course we already said it's definitely electrophilic addition. Okay, so that's fine. Let's move on to the next question. The conversion of Q into R. So that's that reaction, Q into R, right? So that's that reaction there. Uses ammonia. Name and outline the mechanism for this reaction again. So again, what I'm thinking now, in my head, I'm thinking, okay, so now this compound has got a CCl, right? And that's a polar bond. So obviously there's a delta positive and delta negative there, right? So I'm not going to show you, I'm not going to draw the entire structure, but just to show you. So there's your Cl and there's your H and there's a, you know, CH3 and a CH3, you know, a C, yeah? And then blah, 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 yeah? So this bond is polar. That is slightly positive, that is slightly negative. Now, you do not have to write down these, yeah, polarities, yeah? However, if you do show the polar bonds and you get it wrong, so you show it wrong, you will lose marks. But if you don't show it, that's fine, yeah? So it's up to you. If you're going to write this polar bonds polarity, then fine, you know, but do it correctly. And if you do it wrong, you're going to lose marks, all right? Or you can leave it out, as I said earlier. Okay, so now what's going to happen? I'm thinking, well, hold on, ammonia. So, okay, now ammonia, what's so special about ammonia? Notice I'm still writing these attacking species on this side because it helped me remember. Do you remember the ammonia? The special thing about ammonia is that there is a lone pair on the nitrogen. So what's it going to do? Well, this lone pair, it's electrons in it, negatively charged in it. Right, so what's it going to do? It's going to attack that slightly positive carbon, right? Like that. And actually, I've drawn it like this, but it's probably not going to go around very close to the chlorine. Do you remember chlorine's got lots of electrons around it, yeah? So what it's probably going to do, and I might as well correct myself now, is it's probably going to go away from the chlorine, yeah? Electrons, lots of electrons, negatively charged, yeah? They repel, they don't want to be anywhere close, so it's going to attack from the other side. Okay, and then of course, it wants to make a bond, but this can't make a bond because carbon's already got 4 bonds. So what's it going to do? It's going to break the CCl bond. All right, so those electrons, remember arrows are important, they're starting from the electrons and they're going to the atom. So these electrons are going to be transferred to the chlorine atom, and that will allow this to make a bond. So what's going to happen? Okay, so now what you're going to do is it's going to be like this. Blah, blah, blah. And of course, yes, I'm going to show nitrogen eventually, ammonia eventually bonded onto that. And of course, there's a Cl minus, which is just left. Okay, so NH3 is bonded on. But what's happened is ammonia has 3, it's neutral. Now, the nitrogen is using its own electrons to make that single bond here. So the nitrogen becomes positive, which it's not happy about. So what's going to happen is now, sometimes, and I'm going to do this just so you can see, I often actually do this as well. I actually, at this point, I show the NH3 bonds separated out. Why? Because of what I'm about to do now, right? Obviously, this species is not stable, right? Nitrogen doesn't like being positive. So what it's going to do, it's going to lose one of the hydrogens, okay? And the way it's going to do this is it's going to take the electrons from one of the single bonds here, both electrons, to itself. And it's going to allow the hydrogen to leave as H+. Okay, so you're going to end up getting CCH3, H, blah, blah, blah. And please remember to finish it at the end, yeah? Or at least at the end, or actually continue with it. Yeah, I'm not showing it to you because I'm teaching you, yeah? But in the exam, right, you've got to try and do it properly. You know what, you're going to tell me off, aren't you? I might as well do it myself here as well, because you're only going to start writing on the comments about how I should be doing, following good example and whatnot. There you go. Happy? Happy? Okay. Oh, no, you're not. Hold on. Happy. Right. There you go. There you go. Okay. And now, so what's happened is now that H plus has gone off. Okay. So you end up with a H plus here. All right. And you get this species, which is what they've got in their product. Okay, and what do they say? So name and outline the mechanism for this reaction. Okay, so I've outlined it. Remember what I was saying to you? I usually sort of outline it first, yeah? Well, it's obviously nucleophilic. And what's happened between that and that? Well, that chlorine has been substituted for the NH2. So it's nucleophilic substitution. So the name is nucleophilic substitution. There you go. That question done. Okay. Again, be careful with the arrows, please. Yeah. Oh, mistake that students often, I've seen it so many times. It's just embarrassing. Okay. Look at this, right? At this point, students often, and I'm not lying, they often get it wrong because they end up drawing this arrow the wrong way around. So sometimes they draw this arrow, watch this, yeah? The arrow going to the hydrogen. Sometimes they draw this arrow going from the nitrogen to the electrons. Yeah. Sometimes they draw this arrow going from, hydrogen to the electrons. Yeah. This arrow, remember, nitrogen had a lone pair of electrons to begin with. It wants that lone pair back. How is it going to get this lone pair electrons? It's going to get this lone pair electrons by ripping them away from the nitrogen-hydrogen bond, okay, and taking these lone pair. Okay, and then of course you'll end up with this lone pair, which we don't usually show anyway, unless we need to. Okay, let's move on. The next question. State the type of reaction shown by reaction 3. Identify reagent for this reaction. Give one condition necessary for high yield. Again, so many questions within one question, man. Do these people never learn, man? They deliberately try and trip you up. Okay, never mind. We'll get through it. State the type of reaction shown by reaction 3. Identify reagent for this reaction and give one condition necessary for high yield of product when going from Q is converted into P. So reaction 3 is obviously that, so going from there to there. And so what you can see is, well, if things are being added, HCl is being added going from there to there, then it's obviously being sort of eliminated from here. So immediately I'm thinking eliminated. Okay, so that means elimination reaction. Okay, so you can say, oh, that's it, it's elimination reaction. Now you can, and you should know that these kind of elimination reactions happen. These kind of elimination reactions happen with a base. Okay, so that's why. So you need a base for it, and that's why sometimes they're called base or alkali. Actually, not alkali, base elimination. But if you just write down elimination, you'll get the mark. But the more appropriate one is the base elimination. Remember what I said to you, impressing the examiner, keep impressing him or her, and base elimination. Okay, and that actually helps to answer the next question. Identify a reagent for this reaction. Well, if you need a base, then surely it could be a KOH or NaOH, yeah, sodium hydroxide or potassium hydroxide. There you go, your reagent. And then of course, and then it says, give one condition necessary for a high yield of product when Q is converted into P. Q is converted into P. One condition to have a high yield of this, okay? High yield, well, there are a few conditions that you can have, yeah? So you can say that you need an alcohol as a solvent, or you can say the base needs to be concentrated, or you can say you need high temperature, or boil under reflux, etc. Okay, so I hope you found that useful. But remember, you think you know how to do these questions, but you don't. Not until you actually try it yourself. Okay, so give it a go. Try this one. Yeah, I'll try and leave the question in the description below. Print it out and try it, okay, without my guidance. And if you can do that, try some more. If you can do a few questions on this topic, then you can say that you know how to do it. Trust me, practice makes perfect. See you next time.